All right. So welcome to this session. This session is about Apache Spark. Okay. So till now we have covered the distributed file system, the distributed compute. We understood how the distributed compute and file system works. We have gone through HDFS, its commands, its working, as well as Hive. And inside within Hive, Rahul might have told you about how to create table. What It's pretty much similar to SQL if you see it by operations, but the purpose it is used is different. So more or less it supports the SQL. So you can whatever you have learned in SQL, you can apply the same concepts to retrieve and query data in Hive as well. Um, Now let me talk about Apache Spark. So Spark is a general computing framework. Okay, so it supports massive parallel processing. By massive parallel processing, I mean whatever compute we are doing, we can scale it up horizontally across many machines. Okay, so first of all, we will understand how to set up the local environment, and then we will proceed with its APIs like RDD data frames, and how to deal with the data in Apache Spark. So let me share my screen. All right. So you can get the Apache distribution of Spark from this archive.apache.org. So if I open this particular website to you, you'll be able to see this page where you can find the distribution. So I had already copied the entire link for you. So once you hit this link, a download will appear. So this will download a tgz file. This is a tar zip, okay, which can be unzipped using the tar -xf, giving the tar file. Okay, let me just paste that within your chat windows so that you can go there and download this file. It's a small file of 200 MB, so it won't take much time. You can put it on download. So once you download this file, it will look some it will look something like this. So within the file, once you unzip this file, in this file you will have all the directories like bin, conf, data, examples, jars. So this is what the Spark and Hadoop distribution look like. So this particular distribution that we have downloaded is Spark 2.4.0 with the Hadoop version of 2.7. Okay, so here it had provided us all the binaries and the libraries to run it on the Scala as well as Python as well as for Java, because it had provided the jars as well. So what we will do, we will just set up our environment variable and initiate our Spark session. So to set up the environment variable, we need to have Java as well in our system. Okay, so we have already installed Python. How we installed it? We searched Python downloads, and we went into one particular website and downloaded the Python, right? So similarly for Java, we can uh, we can search that onto Google and download the Java for the JDK and the JRE for our system. So once we have the Java installed in our system, we can point the Java home to our directory where it got installed. Like whenever you install something, it will be installed in certain directory. Okay, for Mac users, when you install Java, it will always install in this in this directory structure, where it will be users, your your name of the machine, your username, in the library Java virtual machine, and inside this whatever distribution you have downloaded. So Java, unlike Python, Java had multiple distribution. Like it could be from Azure, it could be from Oracle, it could be from the OpenJDK. Uh, um, you can download it from any distribution. All the distribution are more or less same until unless the version is similar. So here I have installed the Java 11 version, which is called the Java 1.8. So this one is suitable, like for the Spark 2.4, it is suitable to use Java 11. If you try to use Java 16 version, it will throw you errors. Okay. So up until this point, like how to install Java and set up the Java home, is it clear? To download the Java, just go Java download. You will find couple of links. You can even download it from the first website, Java Oracle. Download Java for when you click on it, based on the system that you have, either Windows or Mac or Ubuntu. It will give you the distribution which is meant for you. Okay, so once you set up the Java home environment, another variable that we an environment variable that we have to set is Spark home. So this is Spark home, we will set it to the directory which we unzipped it. So this particular tar file that we have downloaded from this particular link, we have untar this file, and once it is untarred, we are providing that as a Spark home. Okay, so once we do that, okay, these two environment variables are set. So we had to install this find Spark. Let me copy it in your chat window. Pip install find Spark. So this find Spark is a package, okay, which will help us to initialize the Spark in our local Spark library set, because all the other packages that you install are using pip, right? Either you want to install pandas, numpy, you do pip install pandas, pip install numpy. Similarly, pip install find Spark. But when talking about the Spark, we had the distribution right now, and it is not registered in our libs directory. Like if I show it to you, what I meant by this is, like whenever, let's say this is my Python distribution, Python 3.7. Okay, so within the Python I will have such directories. So inside the directories, inside the library side packages, these are the packages that I have installed in my machine using pip. So whenever I install any package, it will create a directory here inside this. Okay, but since this particular Spark is not a separate distribution, and I had to add that inside this. So for this purpose, I had to use this package find Spark, where I'm initializing it and finding my Spark distribution, which is set it on the Spark home. If you don't set the Spark home, then it will throw me an error. Then you can initialize the Spark session using this Spark session dot builder. There you had the options. So when talking about Spark session, so Spark session could be of two types. Okay, one is we are running it in our local. By local, I mean we are running it in our own system, without it's not on a distributed system. Um, the another master could be our resource manager, which is either could be it could be Yarn or Mesos, uh, like based on whatever this resource manager we will be using. So that is the latter part that I told, like yarn, mesos, and other distributions. Uh, that we that we got to know when we will be running this particular thing on a cluster of machines. Because, okay, what yarn actually mean is, yarn full form is yet another resource negotiator. Okay, so this is a resource negotiator by its name. So let's say you had a cluster of machines, let's say 3 machines. Okay, so the yarn will be installed on all of the 3 machines. So how it helps is, it helps to manage the cluster. So we had when we talk of a Spark job, okay, so we had studied about the map reduce, how the distributed compute work, right? So to make the distributed compute happen, one needs to monitor. Like I have talked about, if it is a map phase, everything can be run in parallel. If it is a reduce phase, the reduce phase is used for aggregation, right? So when we are doing things are in parallel, then there should be someone who are looking after it, who is managing everything. Okay, so that is why Spark works in a master slave architecture. Okay, what is master slave? The will master is the one who gives commands, and the slaves are the one who executes the command. Right? That's how the monarchy is. So Spark have two things. One is driver, and another one is executors. Driver is the main driver, or you can call it master, and executor is are the slaves who will execute the tasks. Okay, so when we submit a Spark job, okay, Spark will initiate one driver, which will be sending that, okay, I had to perform, I had to add 1 to all the numbers. So instead of doing, driver will not do this task. Driver will ask executors that, okay, I had to add 1 to the data, and executors will perform this, and driver will monitor it. This is how the master slave thing work in Spark. Okay, so whatever code that we are writing here, this particular thing is executed by driver. I will talk more about this driver and executor thing while running the Spark code. Okay, so as of now, um, we are running this Spark in local. Okay, and I'm giving some app name to it. I gave it Chameleon Labs, and using get or create, it will create a Spark session for me. So if I get the type of my Spark variable, it is PySpark SQL session Spark session. Now, what this particular Spark session can do? This Spark session, using this Spark session, we can create, uh, we can read, write, transform the data sets. Okay, then how do we do it? We will go through it. Let's first talk about the APIs that Spark provide to us to do the data wrangling. Okay, so Spark have these 2 APIs that is available in PySpark. The 3 APIs, in total of 3 APIs are available when we are dealing in Java and Scala, because Spark is written in a JVM language. The source code of Spark is written in Scala. So it supports one added API, that is datasets. In Python, we can only work with RDD and data frames. The another one that I'm talking about is datasets, this particular thing is not supported for Python. Okay, so let me go through it one by one. When I'm talking about RDD, RDD is nothing but a resilient distributed datasets. Okay, so whenever you had gone through Pandas session, right? So there also, what we were doing, we were reading some CSV file, and we can slice and dice the data in Pandas, right? Uh, in Spark, we will do the same, but the difference lie is in how these two things process the data. In Pandas, we had processed it within the machine. Whenever we write, let me import Pandas here. Okay, Pandas is not there. Let me just quickly install it. It is installed. Okay, so if I import the pandas, and I can read the CSV data set. Like, let's say if I have some data which is in a CSV file, so I can give the path to CSV file, and this will read the data, and then I can do all sort of manipulations onto it. But when I'm saying the read the CSV file, how it is reading? It is reading it into the memory, and there we are doing all the slicing and dicing of the data. But when we talk about Spark, uh, Spark uses RDDs. RDD is the most basic building block of a Spark program. Okay, uh, what RDD do is, all the data that you see. Okay, let's say you have. Let me create one RDD, then we will talk about it. So let's say if I have created a text file. Okay, this is some text file. So what I will do here is, I will read that into an RDD. To read something into an RDD, a text file or any other file, what we do is we use Spark context. So to get the Spark context, we can get it from Spark session, Spark context, and whatever file type. If it is a text file, say text file. If it is a Parquet, say it Parquet. Like whatever file type is, we can just say dot, and the file type, it is whatever the Spark context support. So text file is supported by Spark context, so we are storing it in the RTD variable. We can give the path to it. So the path, right now I am right now in this home directory only, so I can simply say new.txt. Executed it. Now the type of this RDD is RDD type. So how it loaded the data is, it loaded the data in a partitioned way. Okay, we have discussed over how a data is stored in a partitioned way, right? Like, let's say we have all these values. If I show it to you using the collect function, so to get the data of the RDD onto the machine, so we can use rdd.collect. So this is nothing but the strings that I have wrote here. This is good tutorial on Python. Let's count the words, put this on. So this particular data set is stored. This is this particular data set have three rows. Okay, and these three rows are stored in a distributed format. It could be a single partition could have these two values, another partition could have this single value. And when we are doing, since it's an RDD, it just provides an easy API on top of it to view it. Like we can perform any operations on top of this distributed data. So this data that you're looking here, this is a distributed data which we have collected onto this machine. Okay, so when this RDD provides an like kind of wrapper, so that we don't have to deal with the complexity inherent to the distributed dataset, and we can perform all sort of operation on top of it. So this is RDD. Okay, now talking about, so up until now, does this thing seems bizarre to you, and you are understanding little bit or not understanding it at all? Mm-hmm. Mm-hmm. Hmm. We will come to that. Uh, no, no, no. It's not a part of Hive. Basically, in a traditional data warehousing scenario, okay, your data might be stored in the other databases, or you might be getting you. Let's say you have bought some data, you have purchased some data from another third party, and you received in terms of files. So now what you had to do, you had to like take the data, you had to perform some validation on top of it. Let's say by validation what I mean is uh, whether the data contains duplicates, or let's say whether it do have any data type mismatches, which the data type that you were expecting, it's not in the same format. um, you can convert the dates. They might be sending it in the Indian time standards, or you might want it to keep your data in all in universal time standards. So all those sort of data cleansing and the validation part you can perform, and can write it into some other location, on top of which you can create your Hive table to query it. So this is how it works. Or you can even read. So spark Spark is a general processing framework. Okay, so you can read the data from Hive as well. You can read the data from anywhere, literally anywhere. Be it the remote S3 bucket, or be it your own file system, be it HDFS, be it Hive. It can read it from anywhere and can write it to anywhere. So that, yeah, we can use it to manipulate the data and write it. So that this is particularly known as the ETL. Okay, so ETL is extract, transform, and load. So what this means is, you will first extract the data. Okay, so this is what we did. Let's say we had some new txt file. We extracted the data from wherever it is present. If it right now it is in a text file which is stored in the file system. So I extracted it. Now we can perform the transformations on top of it, and then I will save this data set after performing this transformation into some other. So this is what ETL means. So this is the generic process that is being used in the all the data warehouse. It's a common process that you had to take the data from somewhere, load it into tables so that everyone can look at those tables, can use it for machine learning purpose, for reporting, for anything, right? So up until now, any doubts on RDD? I will come to the transform part and how to deal with the RDDs, how to manipulate data within RDDs. Okay, so these three are the APIs that is being provided by Spark. Okay, you don't have to confuse with the term API. Okay, it's nothing, but you can think it of as a like it provides some interfaces. Spark is providing some interfaces to interact with the data in a distributed fashion, and you don't have to care about the all the complexity that is underlying to deal with the distributed data sets. You will just handle the manipulation using this RDD and data frames in Python. Okay, so when talking about the RDDs, the RDDs are the basic building blocks. Okay, this is abbreviated as resilient distributed data set. So when I say something is an RDD, RDD will compose of the partitions. RDD dot there is there's one split number or something. So we can just Google it and get the list of the APIs that RDD gives to us. Okay, so this particular RDD is splitted in the backend. Okay, now we were looking at that particular data set. This is I collected onto this machine. Okay, in a single data set, but while looking behind the scenes, RDD is a distributed data set. Okay, so by distributed it could be like one partition of the data is in like these two rows are in one partition, this particular row is in another partition, and it is being dealt separately in it could be this particular row is in another machine, and this one is in another machine, and this one is in another machine. But while you are dealing with a Spark program, you can just simply say you can call your data, and you will be interacting with the RDD at the base level, and you don't have to care about when which machine your data is. It will uh, it will take care of it. Spark will take care of it. Okay, the data frames are uh, another interface through which we will deal with the data. So this inherently is using RDDs only. These both are interconvertibles, but the data frames provides richer experience in terms of data manipulation. I will come to that. We will first see how to manipulate the data using the RDDs, and then we will see how to manipulate the data using data frames. Okay. So right now I have created one RDD. Okay. So let's say someone had given you a problem, and what I wanted is to count the number of words. So by counting, I mean this came two times, good came two times, like this. On came two times, tutorial came only one time. over this data. So this sort of operation I wanted to do. So how I can do it is, it provides these two interfaces to manipulate the data. Okay, one is the map and another one is a flat map. Okay, when we say map, okay, this map will provide all the by using this map we can provide a function which will apply on all the rows. Let's say what I wanted is, I wanted to, let's say, add ABC in front of each string. Okay, so this for applying the function, I can use either a lambda function or I can write the function. So we understood in our Python class, we understood two ways of writing the function, right? So one is using this, let's say, add string, and it will get a string s, and it will let's say it will return s plus abc. Okay, so I can say I will map all my rows with this function, add string. So after mapping, I will get another RDD. So whenever you perform any transfer action, or whenever you perform any transformation on an RDD, it will return you another RDD. Now if I see the contents of this, see, I have applied this using map to all the rows, ABC, 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 right? So I can by using this map interface in the RDD, I can provide all the I can apply a function on all the rows. This function could be doing anything. Another way to write it up is using the lambda expressions. Like right now I had to define the function separately, and then I'm writing it like this. If I wanted to write it in a single line, I can call it lambda. So this is my argument, which is like this one. Let's call it, just to avoid confusion, let's call it s. Now I can just simply type what I wanted in return. So s plus abc I wanted. So now I am doing the same stuff, but not by this function, but by using lambda function. So if I do the same thing, now I got the same result. So this is one function map, okay, which we can use to apply a function to all the rows. Another thing that we can use is the flat map. Okay, so what does flat map help to us? So we have some RDD, we can use flat map. So by flat map, what we mean is, let's say you wanted to split this string on a space so that it will convert it into an array. Okay, let me just take it up like this. So this is my string, I save it into some variable abc, and if I split this onto space, like if I am splitting on space, then I don't have to mention anything, or I can even mention it, it will do the same thing. So if I print abc, what it will give me, it converted this, it splitted this string on the spaces and gave me the array, right? But let's say I had the array. I had the list of strings. Hmm? I had the list of strings. So when I will apply the split function on top of each string, so it will create what? It will create the this particular string will convert into this array. This will convert into array and another array. This will convert into another array. So this will become an array of array, right? But let's say I wanted to do certain operations where instead of getting an array of array, what I wanted is a single array with all the terms. So for that purpose we can use flat maps. Like right now, if I apply this split function on each of the rows in the RDD, let's see what happens. RDD dot map lambda x, and I will be splitting on a space. And then I'm collecting to see the result. So you can see this is an array, and within this array we had array, and the second element is also an array, third element is also an array. So it's an array of array. And for some use case we wanted we don't want this to be an array of array, I wanted it to be an array. So for that reason I can use flat map. So how flat map help is, instead of mapping it onto a single row, it will keep it into a buffer, and it will merge all the data of the rows into the key value pairs. Like it will help us to generate the keys for a textual data. Like just for example, if I tell you, because we wanted all the keys into same array, so this flat map helps to flattening the structure for our data. So if I run this again by using flat map, now you can see the response. This will convert it into a single array. This is a good tutorial on Python. Let's continue the words code this on. Got the difference between what is map and what is flat map? Like wherever we wanted to flatten the structure of our output, we can use flat map. Okay, let's do a small exercise. Let's say we wanted to count the number of words. Like this came 2 times. So okay, you might be confused over lambda. What exactly lambda is? Let me call you. So what does lambda do? This lambda is nothing but a short form. Okay, a short form to say of a function. So this what this mean is, it will take an argument which we gave as a variable s. Okay, and it will return s plus this abc. So it is the same thing that I have written in this add string, but in a more compact way. If you find it hard, you can still be with this function definition. You can write the functions like this. Just for sake of simplicity, uh, for compactness, we can use lambda functions. Okay, both are same thing only. So here I'm saying lambda x to x dot split. So you can translate it into a function of def. Let's say I give some name, split on space, and it will take an argument x, because this is what we gave the name x. And what it is returning, the return x dot split. So if I execute this and use this function instead of this lambda expression, I will get the same response. Got it? Okay, now who will tell me? Um, we had reached, my RDD contains this data now, and we had already discussed over what map do and what this flat map do. So till now we reached that after doing the flat map and splitting on a space, I got my keys, all the keys. Now I wanted to count on I wanted to perform the counting on top of it. So how can I do that? Just think from your SQL mind. When I had a column, okay, I had a column where I had all the um, keys, and I wanted to perform a count on top of it. So in SQL, what I will be doing, I what I can do is I can select my data like this key. Let's call it the first value, first column as key. The second value could be, we could have one as vals from the particular data set, and on this particular data set I can now perform the counting on vals, or I can just add up the vals. Like I can use it as a subquery. Let's say select key comma sum of these vals from this data which I am grouped by on keys. Won't this query give me the key value pairs? Like this comes this many times, this comes this many times, because I have first placed the one, and now I just added up the one grouping on the keys. So I will try to do the same here. So iterating on the each row, first I created this key comma 1, so we will convert it into the key comma 1. Now to in when we have to perform the aggregation in an RDD, okay, let me just give a quick insight to you how, when we perform this operation x comma 1, how it looks like. We just created it like this, created into a key value pair. Now what we had to do, we had to perform a group by on my first value. So for that there is a reduce operation. Okay, so in this reduce operation, now we are reducing it on key, which is key of the key value pair. This is the particular method that is by RDD itself, and this take a function with two arguments. Let's call it a and b. Okay, now what this a and b are? A is the one which accumulates, okay, and b is the one which is the current value. Okay, so by this thing, what I mean is, let's say I have reduced on the key, and I encountered with on. Okay, now this on, for on I have 1, so accumulates always start from 0, because and the current value is 1. Then another, again my on will encounter, that means accumulate, I need to add up this to it's to increase my accumulate value. So every time whenever I return this value, it will return to set the value of a. So it's more like a equals to what? I wanted to set it to a plus b, because I wanted to increase my accumulate value by the current value. That's how I will perform the sum on top of it. So what I can say, a plus b. So this will help me to perform the count on top of it. See, good came 2 times, on came 2 times, rest all things came 1 time only. This also came 2 times, but here the t is capital, so we can put one more step in here, where we will be like, we can chain these steps together. I can lower my x, I don't remember whether it is x dot lower, like string dot lower, or how is it. So if I have a dot lower, do it works? Yeah, it works. So this will work as well. Now this is 2 times, because we already lowercase it. So if you see from the starting, I had read the file, I have performed a flat map by splitting onto the space, so that it will get the keys. Then I have lowered the values by doing lower, that means all the values inside the string will convert into lowercase. So after converting all the values to the lowercase, like since it is all the rows, now I mapped all the rows with x comma 1, and then I am performing the sum of this second value grouping on the first value. Like reduce by key is nothing but it is performing the grouping on the key, and then what I wanted is, I wanted to sum up the values, sum up the current value every time which I collected. Like this is so are you getting any are you understanding this part, or is it totally unclear to you what I said? You understood a little bit? How is it? This particular word count problem is a pretty standard question that is being asked in an interview. So interviewer might ask you how to do it using the RDD, how to do it using data frames. We will talk about the data frames after this. Once we are all on the same page and we are all are clear with the concept of RDD. So here you can see we can pretty much do anything on top of the data, since we can apply any function. We can write anything inside a function, right? We can apply any function on top of all the rows, and then we can perform the aggregation as well to get the outputs. So this is a traditional thing that we had to do to get our answers. Either either we had to apply some functions, we had to perform the aggregation, or the third part is filtering of the data. So how we can do the filtering? So to do the filtering, we can apply filter on top of any RDD. So this how this filter works is, again, it will take a function and this function, it had to return a boolean value, like if whether true or false. Okay, so I can say if my second value, since they are tuple, 0 will be the first value, 1 will be the second value. If my second value is greater than 1, then only show me the result. Otherwise then on this will hold true only for the values where the second value, the x of 1, is greater than 1. So if I perform the collect on top of it, what will I get? I will get this good and on, because these are the only values which holds true for this filter. Make sense? So we can apply any sort of filter, because we had to apply we do apply a function to get the true and false values. So within a function we can write whatever sort of logic we want to apply a filter. Any doubts? Anything on RDD? No. Basically, whenever you perform, why it always. I guess since it's not a paid version of Teams, it only provides us 1 hour. Hmm. Let others joins. I guess everyone arrived, right? Oh, there is one more person, Shriyesh. Okay, till the time, let me answer your query, Soumya. So whenever we perform any operation on top of RDD, like either it is flat map or map, filter or reducing, so whenever we apply any function on top of the RDD, it will return another RDD. Okay, so RDDs are resilient. By its name, it is resilient distributed data set. That means it it will, once it is created, it is never, you can never change it. Okay, every time you perform any change or any transformation on top of it, it will create a new RDD. Okay, just for example, let's say this RDD, you performed a flat map operation on top of it, so this will return a new RDD. Like I can write it in this way. Let's say this is RDD1, which is returned by this flat map. This is RDD2, which is applying this operation, this map operation on top of this RDD1. Then I can say this operation is applied on RDD2, and I got RDD3. Okay, so here you can see this particular RDD, if I apply some function on top of it, I will receive an RDD. So you are in a way you are transforming the data, but you are not transforming the RDD. This RDD once created is created. It will not, it cannot be modified. Uh, this by capitalizing on top of this immutability, Spark is able to run massive parallel processing, because if let's say RDD could have been manipulated, then there could be a lot of manipulation by multiple machines at a multiple time, and we could be running multiple processes, and that would end up being in, everything will end up being in a race condition. So these are always immutable. Okay, and every operation on top of RDD will return another RDD. Okay, and I chained it directly by using dot and dot and dot. You can do it like that, or you can store it in another variable, and then you can do it. So it's just a way of writing, nothing else. How I am able to do it, because let's say this is RDD2. I am applying this map on top of RDD2. If I wouldn't have retrieved it into a variable, I could have, right now I am doing RDD2 dot map. So I can even replace the RDD2, right? Like this is how it is. Like just to give more sense to it, this I gave a equals to this and this lower, so this gave me small a, but I could have directly done it on my string without storing it into a variable. So that's the same thing that I have done above. It's just a matter of whether I wanted to put it into a variable or not. All right. Actually, there is no better or there is no right or wrong way. Okay, let's say you wanted to let's store up until this point in RDD3, and what I actually wanted is, right now I perform the two steps directly, right? And what I actually wanted is, um, I wanted to print this one, as well as I wanted to perform the filtering as well. So let's say print rdd3 and dot collect, and I will print this one as well. So if I wouldn't have stored it into a variable, then I would have to write all of this, right? Again. So it's just what you wanted to do. Okay, there is no right or wrong. You can write it in either way. I will come on another concepts of it. Okay, so if you are clear with the RDD, like it's really important in terms of interview. When you are when you're working in the industry, you will seldom use RDDs. Most of the time you will be dealing in the data frames only, because it's more structured in a way and it is easy to use. Okay, uh, this we had to understand from the interview perspective, because in most of the interviews, interviewer will ask you uh, to perform these simple operations, like to they will give you this problem, let's say word count problem, and ask you to run the query, to write the Spark code for it. Then you had to think in terms of RDD, or you can also do it in terms of data frame, but sometimes interviewer just restrict you that you had to do it using RDD only, just to test whether you had the knowledge of the very basic of Spark or not. Okay. Sure, I can share it with you. Like we can directly find it on the internet. I will just redirect you to the right URL where you can find it. Okay. So this is all about RDD. Okay. Uh, but before moving forward, I want to talk about two things. We have talked about the transformations right now on the data. We haven't talked about the actions. We had only talked about the transformation. So what do we mean by transformation and action? So in Spark is a lazy evaluator. Okay. By lazy means until unless I will ask the result, it won't compute it anything. Let's say right now I am performing this collect operation. If I don't, then what will happen? It's just an RDD. I cannot print it. Okay, and up until this point, let's say I created this RDD, and then I have added on top of this flat map, then I have performed some map operation, then again another map operation, reduce by key, send some filtering on top of it. But up until this point, there is no all these things that I'm doing is transformation. So Spark will not evaluate anything up until we call an action. What is an action? We are saying collect. Collect is an action, because we had to collect all the data which is stored in RDD3 onto my machine, or or any variable if I am assigning it to. Okay, so whenever I wanted to retrieve something out of the RDD, that is where the action is performed. Okay, now what does this action do? Action will trigger this evaluation. Okay, so up until now, what Sparks do is it creates a lineage, like it had to perform this operation, and from RDD2 to it had to create this RDD3, from this it had to create the RDD4, and this is what is being collected. Okay, so when you hit collect, what it will do, it will check whether the RDD4 is available. So if it is not available because it is not yet computed, this we can directly compute from reading this text file. So it will read the text file, then perform these operation, and then perform the collect on top of it. Up. So if I remove this step, if I remove the action, if I keep all the transformation, is there any computation that I am doing till now? No, I'm not doing any computation. It will only compute things when my action is called. Collect, or if I wanted to count the number of rows in the data set RDD4, or another action is for each. If I wanted to iterate on each of the row and apply such certain thing without returning anything. So these action will trigger this lazy evaluator and evaluate all of the preceding RDDs. That's how the Spark works. Okay. So this is about RDD. Now let's say what is data frames. So we up until now we are very much familiar with the tabular structure, right? Tables. We have talk of tables in Hive. We have talk of tables in SQL, in Excel as well, right? So this particular table structure we can also create in Spark. How we do it is, for that we don't have to go to Spark context. Let's say I call it as a data frame. So Spark dot read dot, now I had to give some file that I wanted to read, a CSV file or a text file. So let's say I want to read a text file. Which is not as written as this, it is written as this, which is new.txt. Generally we call everything as CSV, so I'm not sure whether this .txt will work. It did work. So here you can see, generally if it is a CSV file you will call .csv. If it is a, let's say instead of comma separated file, it could be a tab separated file, or delimiter could change. So for that reason you can provide the options on top of it, like what is my delimiter. If my delimiter is something, let's say comma, which is the default for CSV, then you don't have to mention it. If it is something other, let's say double pipe or some other, then we can mention it specifically and can read the data set. So now if I do the df.show, so this is my table with a single column value and these 3 rows. If right now my values are truncated, so if I wanted to truncate, I can say truncate equals to false. This will remove the truncation. F is capital and false. Yep. So now it looks more convenient because it's a tabular structure. This is what a data frame is. So you will interact with all the data in a tabular form, and here you can create columns, you can drop columns, you can pretty much do anything on a tabular structure like we did in SQL. Okay, let's say we wanted to perform the same thing that we did above. We wanted to count the number of letters. Okay, so for that, what we can do, like in the SQL, from the SQL context, like we had already discussed, what we would be writing some query like this. Yep, to perform the grouping. But to perform the grouping on the key, I first need to have the keys. Like one key should be the one row. This should be another row. This should be another row. A should be another row. Then only I will be able to perform this, and I will get the answer, right? So let's see how we can do that. So similar to how we did in RDD, we can also use map functions here. But instead of mapping, what other things that I can do here, we can do here is we can create new columns. So let's say let's create a new column. To create a new column within a data set, in a data frame, we can use this particular function with column. You had to add a column name, let's say call it keys. Okay, and then you had to give what you wanted to perform. So this particular column, which is value. Okay, now to write a column in this PySpark, you had to import some functions, which is import PySpark dot SQL dot functions sf. So I'm loading this SQL functions as f. So to head a column, I had this function f.call. Like you can check out all the functions that is available in this SQL functions package. I will give you the link, and you can go through it, where it will teach you all the functions that are being available in this functions package. It would be column, literal, and the average is sum, and couple of other things. So to select a column, we use f.call, like this column function, call function in this functions package, and we can mention the name of the column, which is value, and whatever we wanted to do on top of it. What we are doing is splitting on top of it. So if I do this then and show this, let's say if what happened if I don't mention show. In Java it was like that only, but I guess we had to see another function, which would be you can check this out. Yep, this work. Like in SQL, like basically this functions package contain all the SQL functions. Like in the SQL, we can write all the function like lower my string column, right? So whatever functions that I wanted to apply on top of the columns, I will import, I will use those functions from this functions package. I wanted to split, like in normal way how you could have a split. Since if you wanted to split on a string, you could have simply said that string dot split, but since we are applying it on a column, we cannot do it like this. We had to use the functions package. So I'm splitting on this, but as you can see, When I applied this with column, it added a new column keys, but it returned as a data frame only. So every time I apply any operation on top of the data frame, any transformation on top of the data frame, then it will only return me a data frame, like similar to the case of the RDD. So let's say we store it again into the DF. If we see the DF, show is an action. So up until this, there is no computation. It's all just chaining of operations. So to compute this DF, I am performing an action. So if I say false, F capital, truncate. So now you can see I have splitted it in the same way, like I had split it using map. Now this is one array, this is another array, this is another array. But instead of being in an array, I wanted it into columns, right? So what I could have done, I will select these two values, this first column, that is, so I don't have to select the first column as well. So there is an explode function. This explode function helps to convert an array to rows. Like this particular function exists in SQL, that is why it is here in this PySpark SQL functions. So if I do this, bracket close, then I can see all of it is now in single row. Right? I can, just to avoid confusion, and this query like df, I can say we were saying to add one more column, right? So that we can perform the sum, we can perform the group by on top of it. We can say this vals is another column where we are giving only literal value 1. So if I execute this, what it will do, it is in the tabular structure, I am adding one more column with a static value 1. Now what I can do, I can just perform the group by on top of it. These are all the operations that I'm doing in the data frame. I could have done it using SQL as well. So if I had to perform a SQL step on top of a data frame, okay, so we had a function called register temp table. Okay, so doing this way, we can register it as a, let's say I call it temp tbl. Okay, so by doing that, right now we are performing all the data frame functions using with column, adding new columns, and selecting the data. We know how to select data in SQL, right? Select a star from the data set. So in the data frame as well, we use the select function to select the data, select which column I wanted to select. So I wanted to select the keys, but on top of it I wanted to explode it. So we did it like this, like just to showcase it to you. Now I have registered this data frame as a temporary table. How can I access this temporary table? Spark.sql, and now inside this I can write the plain SQL that we know. Select this star from this temp table, and since it will return me a data frame again, I can call an action to get the values. It is returning the same thing. I could have done it in either way. Let's say I this is the initial data frame that I had, okay, and what I wanted is um, I wanted to create I want to register this as a temporary table to call it into a SQL init table, okay. Now if instead of this, if I say init table, this is my initial table. Now I'm able to access the same thing, the same data frame, but by using SQL queries. So this is another API that is provided by Spark on top of data frames itself to run the SQL queries on top of the data frames and get the answer. Like it, this will the return type of this particular function is data frames only. So this way I can play around, one in the SQL, one query in the data frames. I can write the query in whichever way I wanted. Let's say I have came to this original data set, which is this one, right? And I wanted to come to this state by running the SQL on top of this data frame, okay. Then we can apply pretty much all the similar function that we had run through. Like the first thing that we did is, let's go, we created a new column which is keys, which is split on the values. So we had underscore c0 column as value. Then we had another column as keys, which is split of my c0 column on space as keys. So if I show you, we have came to the same grounds, values, and we split it into this. If I further look at this, I can encapsulate it into an inner query, select my explode of keys as call from this data set. What it will give me? It will give me the same thing that I have achieved. What I am doing, exploding on the keys that I have generated using the split function. I performed this operation using this with column and then selecting the explode on top of keys. I did the same thing using a SQL. Then can I add another column? Yes, like we did in SQL. One as wells, I can add it. So if I execute it, I came to the same thing just by doing SQL. So that is why the SQL have so much importance, because even in the data transformation and even while running through Spark, doing the ETL, you can pretty much write all of your ETL using SQL. You don't even have to work through the data frames APIs. You can keep whatever dataset you wanted to interact with, register it as a temporary table, then you can just jump into SQL part of it and can write the SQL to perform any transformation that you want. So it's totally a choice whether you wanted to write it in this way or in this way. The performance of both the things are similar. So just to complete this question that we once started, we wanted to count the number of keys. So for that, what I will do is I can write it into, let's say I let's not bloat it up. Let's say I store that into another data frame, tf1. Okay, and then on top of this data frame, what I will do, let's say we perform this entire query in SQL, so I can register it again into another temp table. Let's call it table only, and I can say Spark SQL, and from this table what I wanted is my column and the sum of my vals as count from which, from this table that I have registered. What is the content of this table? This data frame df1. Df1 created from running the SQL query. So will it give me any result? No, it will give me a data frame only, because I'm running the Spark SQL. It will give me a data frame, and to show the data frame onto my console, I can do like this. What's the issue? Grouping exception. See, if you read the exception, you will come to know what the exception is about. It is a grouping like this particular column. Call is not an aggregate function. This tell me, since I am summing on the vals, then call should be the column on which the aggregation is performed. We haven't performed the group by. If we say group by on the call, then it will be all fine. We came at the same step. This we did it in RDD. Here we did it using data frame. So I guess we had gone through the entire data frames step, so you might have got some idea what exactly data frames is, and how we are dealing it. Like data frames are nothing but a tabular structure, a frame in which we are keeping the data, which is tabular structure, and we are interacting with the tabular structure using the either the data frames API, or either we can do it using the SQL. And these two we can use interchangeably every time, whenever we want, like this. So any questions on top of this data frames and or on RDD? Any questions? Well, you will get to know more about it once you will set up the environment and try to do it on your own. You will hit on some errors. You can then correct them. Then you can try playing around with the APIs, like to play around first by doing something on top of SQL, then converting back to data frames, then running something in data frames as well. Like the end goal is we wanted to see, we have started from this point and we came to this point. So this is what? This is a transformation of the above data. If you wanted to save this data, how to save it? right now I call the show action. So instead of calling the show, I can store it into some another data frame, and here I can say write this data frame. So this function write, this will create a data frame writer object, and then I can decide in which file format I wanted to write it into. Like, let's say if I wanted to write it into a CSV file, so I can give the name of the CSV file, let's say um, the new transformed dot text file. So it ran this file, and now I can see there's a this one is new .txt. Here we have created new transform.txt. And now here you can see we had quite a lot of part. So what this all this part signify? I just wrote a text file, but since Spark do it into a process the data in a distributed way, so it had if I go in the part, you can see this particular part carry only single record. If I go to some other part, this doesn't carry any data, this carry only single record. One or two part might carry two records or more than two records as well. So this showcase that this particular thing is in distributed way. It has splitted up the data in multiple partitions, and then processed each partition in a separate way and wrote that. So let's say I wanted a single file instead of this multiple files. Then what I can do? I had certain things like repartition coalesce. Like this particular this repartition in coalesce, what it do is it tries to do the data like it's try to change the number of partitions and the partitioning as well. So we will talk about it like just for in the next class maybe, because it's already 8:10, it's already 1.5 hours. um, so just to finish off the session, I can show it to you. Let's say if I repartition it to 1 and write the CSV, it will throw me an error because it's we are trying to overwrite a certain file. So we had to strictly mention that we wanted to overwrite it. Mode overwrite, then it will be all fine. And now we can look at the file. Since we merge all the partitions into a single partition by repartitioning, now we had all the data in a single file. We will talk about the repartition coalesce and other things about the data frame APIs in the next session. Until then, I will send you through a few of the links which you can go through and check out what other data frames APIs are, and you can play around with it. You try using them. As you already know how to set up the environment. Now you can set it up your environment in local and try out. So any questions for today's session? If no questions, then we can close this session. Yeah, tomorrow we will be having a class. We will be having the class on the same topic, Spark, and what we will do, we will try to try to solve a use case. Like we will first go through a couple of the APIs for this for the data frames, and talk about what lineage is, transformation and actions, and then we will go through a use case. Okay. um, any other questions? We are left with only 3 people by the end. Okay, I guess this session went too long. Okay, all right. Bye bye.